In this session, we are going to cover linked lists. So now let us open up the terminal app. Let us create a new file named as linkedlist.c. Before we get into linked list, we have to understand why do we need linked list and what is dynamic memory allocation. To understand dynamic memory allocation, we will define a struct and then define an array of that struct which is fixed. I'll give the size as 3. So hash include stdio.h int main return 0. Okay, now I'll create the struct. I'll name it as number. Number. Now I'll declare int variable as number and a string variable char number as number name. I'll give the size as 20. Now I'll create the array of the struct number. I'll type def struct number. I'll go to number. I'll name it as num and give the size as 3. Now I'll take the entry through a for loop. So I'll do a hash define give it as max and then give it 3. I'll use max here and max here too. So I'll declare int I is equal to 0. I'll list then max I plus plus. Okay, now I'll take printf number scanf %d as it is an integer, and I'll take num I dot number. Okay, copy this, paste it one more time. I'll give number name. I have to also change the format specifier to %s, and this one is number name. I'll also give us \n. And then I'll print the values. I'll copy the whole for loop. Delete that. Copy this printf. So the %d number name %s. And give the variable I plus 1. As I initialized I with 0, I'm adding 1 to the number, so that I'll start from 1. Then I'll give the array name, which is num I dot number and num I dot number name. Okay, Okay, back. So now I'll compile and execute this code. gcc linked list don't need ampersand. Clear the screen. Okay, there are no compilation errors or warnings, so I can continue. Number, I'll give it as 3, 3, then 6, 6, and then 1 and 1. Okay, it's printing the values 3, 3, 6, 6, 1, 1. Okay. Execute this one more time. Okay, so I'll give first as 1, then 9, 8. I wish that I could enter one more value, but I can't because I set the size of the array as 3. So I'll go back to my code and change the size as 4. I'll have to compile it. There are no compilation errors or warnings, so I can continue. Okay, I'll give 1, 1, 7, 7, 2. I wish if I have to only enter 3 values, but I have to enter 4 values because I set the size as 4 of the array. This is 4. Now you see that I have to go back to my code, change the array size, recompile and rerun the code. Is there a solution to fix this problem so that when I'm entering the data, directly it will allocate memory? That means how much memory I want, not more or not less. Okay. So for this, I have to use dynamic memory allocation. So let's go back to our code and I'll comment the entries code from where I'm taking the entry and change the array as a variable, a pointer variable. Okay, now I'll type in a while loop, infinite loop. I'll comment this too. Okay. In the while loop, I'll allocate some memory. Okay, so I'll do it like this. Now I'll give the cast type. So I'll give my struct's name the the number. Then I'm going to allocate. So for that, there's a function known as Malloc. In that we have to pass in the size of that specific struct. So number, this mine number. Okay. So this is how we allocate memory. Now I will take the user's input. So I'll give a printf number. I'll copy those lines, these 4 lines. Okay, I have to change the variable name, and I have to give arrow like this, and over here too, num instead of dot. I have to use arrow. Okay, now I'll also declare a char variable known as cont. So now I'll take the user's input to check whether he wants to enter more data or not. So I'll give do you want to continue. I'll give y/n scanf. I'll also flush the input buffer. Student. This is %c as it is a char, and $cont. Now I'll give the if condition to check whether the user has typed y or no. So I'll give y if cont equals to small y, or I have to give and. It's like this, cont equals to capital Y. Then it will break the loop. Or else it will continue. I'll just give else. I'll also print where it's getting stored, the address. So I'll give value %d is stored at address %u as the format specifier. Now to use new number, I'll use number and new. Okay, so now let us compile and execute this code. So now I'll compile it. Go back to the code. Oh, I wrote new instead of num. And here, so now I'll import the. I'll go back to the code and import the stdlib header file. Input. Okay, there are no compilation errors. So I'll now execute it. Okay. Oh, I gave this line after the do you want to continue. So I'll compile it again, clear the screen, out. Okay. I'll give it as 2. Okay. So the value 2 is stored at 179090. This is the address where it's stored. I'll give y. Number and I'll give 3. Okay. Now see the address is changed. Now I'll give no. Why didn't it stop? Let me give not equals to here. Try it again. Compile it again. Okay. Clear the screen. Excuse me. 3. Okay. I'll give 4. Okay. It break the loop. Now, since I have only one pointer, it can only hold one the address, right? It cannot hold this address or any other address. It can only hold the last address from which I entered, right? Now what if I want a previous one? I cannot, because it's only storing the last address, right? Is there any solution for this? Yes, there is a solution. The solution is to link all the values, all the data, the previous data, the current data, together like a chain, which this forms a chain called as linked list. See how to type what is the code for a linked list. So let us go back to our code. Now I'll declare a variable of struct number inside itself. So I'll name it as next. I'm taking pointer because it will store the address. Okay. Now I'll change the num as new, and I'll declare another variable known as head. The head is the beginning of the linked list. If we don't have the head, we cannot find the whole linked list, means after the head. So now I'll allocate memory for the head. I have to change the variable name. So I'll assign new with null head 2. Now I'll check if head is null, then it will make the head as the new node. Okay, the node is the set of elements of the struct. Okay. Now I don't need this allocation, so it's fine. Now I have to also, I don't need this line, and in the else in the new next, which is head right now, I'll allocate a new memory. So I'll call it from here, and so what does this line of the code do? After it has allocated some memory, it will return the address where the new memory has been allocated. So I'm storing that new address in the current node, in the current node's next. Okay. Here the current node and the new node is getting linked. I will shift the pointer to the new node. So why am I going to do this? I'm going to do this because I have to also accept the entries for the new node, and I have to also change its next to null until I decide to continue, okay? So that it will create a new node and change its next. Now if I don't create a new node, if I say no, then it will be the last node. Okay, so I have to give new equals to new next. Now I'll change the new node's next to null. We don't need this if condition, because at this position the head will always be null. So now I'll compile and execute this code. So gcc link list.c. Oh, I did not change the variable name. Okay, I have to change it to new. Okay, I'll also change it here. I'll comment. Oh, there's another error. I forgot the semicolon. So I'll clear the screen, and then I'll. Okay, there are no compilation errors, so I can continue. Clear the screen, cut out. Okay, so I'll give the number as 3. Okay, so the value 3 is stored at this address. I'll continue. I'll now give me 0. Okay, now I'll type in another one. I'll give 9. Okay, so I don't want to continue, so it's no. Okay. Now I'll give the code to print the values which is stored in the specific nodes, the first node, second node, third node. So I'll go back to the code. I'll not use this for loop anymore, so I'll delete this. To print the value, I'll take a cur variable pointer, cur equals to null. Then I'll copy the value which is stored inside head into cur. Then I'll give a while loop its condition will be cur not equals to null. So when the cur will be null, then it will break the loop. Okay, so I have to get printf number %d. This one has cur this one cur number. Copy this line. Name, I'll give the space, and number name. Now how do we go to the next node? So for this we have to give cur equals to cur next. This will go to the next node. Okay, it will print a value and again do the same thing, and when it's null, then it will break the loop. Okay, so now I'll compile this code. Okay, there are no compilation errors or warnings. So I can continue. Okay, take 7 and then continue 0 1. Oh, I forgot the \n. /n, clear the screen, compile it. Okay, there are no errors. 7. Okay, I want to continue. 8. I want to continue. Now I have 9. I don't want to continue. Okay, it's working. As you see, it's printing 7, 8 and 9. Means our programming is working fine. I felt that this topic is pretty difficult and complex to understand. In the upcoming sessions, we will build an application including files and linked lists and features like create, update, delete and search records. Thank you for watching this video, and I hope you found this video interesting.